Hello, welcome back for the second part of lesson 5.4. And we're working with trigonometric functions and finding them, their exact values using reference angles. And so here we are at number 33. It's asking us to find the sine of 150. And to do that, it's best if we know its reference excuse me, its reference angle. So 150 is going to be into the second quadrant here. And so that means that its reference angle is, I'm going to highlight it so you can see its reference angle is really going to be this angle right here. So that means we're going to take 180 and subtract 150. And so the reference angle is really a 30-degree angle. And we know that sine, using our table we've been making, our sine at 30 degrees is 1/2. So 1/2 is the answer. Okay, cosine at 120. So cosine at 120 is also in the second quadrant. So again, we're going to take 180 minus 120 is 60 is the reference angle. And cosine at 60 is also 1/2 because they're co-angles. Tangent at 225. So 225 is not in the first or the second. It is into the third. It's down here. So its reference angle is going to be right here, which is, this time you're trying to get to the x-axis. So you're going to say 225 minus the 180 is going to be a 45-degree angle. And so tangent at 45 degrees, we're going to go to 45 degrees, it's a pi over 4, and tangent is 1 there. So number 45, we're looking at secant of 150. And we know that 150, the reference angle is 30. We did that back on 33. So reference angle is 30. And so secant at 30 is 2 square root of 3 over 3. And it's negative there. A negative 2 square root of 3 over 3 because cosine is negative. So my tangent in the 41 should have been a positive 1 because they're both negative there. This one, cosine 37 should have been a negative 1/2, I believe. Yes, when I look at it. Make sure that you're taking note of where sine is positive in the second quadrant, so that's okay. So I need to keep paying attention to that a little bit more. Tangent of a negative 45. So that means we're going in this direction, 45. So its reference angle is 45, but it's in the fourth quadrant. So tangent in the fourth quadrant means it's 45 degrees, tangent is 1, but that means sine is negative and cosine is positive. So tangent will be a negative 1 there in the fourth quadrant. Cosecant at 180 is right here on the x-axis. And cosecant is 1 over sine. Sine at 180 is 0. So this is going to be equal to 1 over 0, which is going to be undefined. '63 says, oh, now we want to find the exact value. We're doing some mathematical operations with our trig functions. So cosine at 120 Up here, we know that cosine of 120 is a negative 1/2 minus sine at 120. Remember, 120 is a 60-degree angle, so sine at 120 is positive in a positive square root of 3 over 2. Square root of 3 over 2. So that'll just be a negative 1 minus square root of 3 over 2 for 63. Did I write that down correctly? Cosine of 120 let me go back and look at it. I think I may have written it down incorrectly. Cosine of 120 minus sine of 210. Yes, I was going to say, I don't think let's just rewrite this. Cosine of 120 minus the sine at 210. So cosine at 120 is a negative 1/2. Subtracting sine at 210 is going to be a reference angle of 30. So, and it's in the third quadrant. So sine is now negative. So sine is going to be negative. Make sure you have that. So you're subtracting a negative. And sine at a negative, sine at 30 is also 1/2. See, sine at 30 is also 1/2. So a negative 1/2 plus 1/2 is 0. It didn't look right that I wrote that down. 65. That's what happens when my contacts are not in and my glasses are not working well. So 65, we have tangent of 120 plus the cotangent of 135. So tangent of 120 is the reference angle of 60. So tangent at 60 is the square root of 3. So the square root of 3 plus the cotangent of 135. 135 reference angle is going to be 45. And that one was 60. I have to add to 180. So 45 is my reference angle for cotangent. 45 and cotangent is a 1. Except for it'll be a negative 1 because it's in the second quadrant. And I believe tangent is also a negative square root of 3 on that one. Yes, they're both negative because cosine is negative in the second quadrant. So it's just a negative square root of 3 minus 1. So these are all using the reference angles to help us find that. Okay. Let's move my camera up to that number 7. 73 and 81. Okay. So 73 says tangent at pi over 4 minus cotangent at pi over 4. So 5 pi over 4 is into this third quadrant by 1/4. So it's a pi over 4 reference angle. It's a 45-degree reference angle, and tangent is going to be negative there because of cosine is negative in the third quadrant. So tangent at 5 pi/4 is a 1, so it's going to be a -1. And then subtracting cotangent at pi/4, so that means cotangent in the first quadrant, where at pi/4, where they are both positive. Oh, tangent is positive in the third quadrant because it's sine over cosine, and they're both negative in the third quadrant. At pi/4, they're both positive in the first quadrant, so that's going to be a +1. So we have 1 minus 1 is 0. There we go. Okay, 81 and 85, they're giving us the terminal side. There's some restrictions that we have to follow here. So we want to find the secant of theta, the angle, if we know sine is a -5/13. So let's draw this. So it's in the third quadrant, okay? And its sine is 5/13, so the hypotenuse is 13, and the adjacent side is a -5. And we need to find our other side because secant has to do with cosine. So we need to know what the adjacent side is for secant. So I believe it's a 5, 12, 13 triangle, but let's just show that. So we know that a side B is equal to the square root of our hypotenuse, 13 squared, minus a squared, which would be a -5 squared, which will still be positive. So the square root of 13 squared minus 5 squared, 12 it is. It's a special triangle, 5, 12, 13. Okay, so this is 12. And so secant of that angle is going to be 1 over cosine. And so 1 over cosine. Cosine is the adjacent over the hypotenuse. So it's going to be the reciprocal of that. So it should be 13/12. Oh, and cosine is, it's a -12 because it's in on that axis. So it's a -13/12. I keep forgetting to pay attention to what quadrant we're in. Okay, let's try another one. 85 has another one similar that has a restriction. So this one says, find the cosine of theta if sine of theta is a -1/5 and the terminal side of theta is in the fourth quadrant. So we know we're in the fourth quadrant. Okay. And sine is a -1/5. Cosine is positive in this quadrant, right? First and fourth, it is. Okay, so we have to again find our adjacent side, B, by taking the square root of 5 squared, subtracting -1 squared. So 5 squared subtract 10. And we can even make it a -1 squared. So that's going to be the square root of 25 plus 1. So it's going to be the square root of 26. Oh, no. 24. Yes. And the square root of 24. So our answers are going to be square root of 24. You could also, if you wanted to simplify it into the square root of 4 times the square root of 6, this could be 2 times the square root of 6 if you wanted to simplify it that way. And so cosine there of that angle is going to be the square root of 24 over 5, or you could write it as 2 times the square root of 6 over 5. Either of those would work. And then we have a couple fun ones that they throw in there that's like, hey, can you use your calculator? So 89 and 97 are like, let's just use our calculator. Mainly, we just have to make sure that our calculator is in degree mode, and it is, because we're going to put in degrees. And the first one is just, what is the sine of 157? And it comes out to be 0.39, 0.3907. And then the other one is cosecant, and that makes it a little more challenging because we at least have to do 1 over sine on that one. 1 divided by the sine of 315.4. And that comes out to be a negative 1.4242. And then the last two problems I have for you are fun problems, fun story problems at the end of Sine. These are, and number 99 is where I'd like to start. So 99 says, in the given illustration, find the distance from the top of the pole to point A directly below it. And so I think my picture is pretty good. That's what we're trying to find. So we know this angle here, it stops and it's 150. So that means our reference angle is going to be 180 minus 150, or 30 degrees. So our reference angle is 30 degrees. And we are looking to find the opposite, and we have the adjacent. So the opposite, and we have the adjacent is 20. So opposite over adjacent is tangent of 30 degrees, right? So to solve for opposite, we can say our opposite is equal to 20 times our tangent of 30 degrees. Make sure the 20 is out in front. And so 20 times the tangent of 30 degrees is going to be 11.55. Excuse me. 11.55 feet, I believe it was. We know also the tangent at 30 degrees. I think that's one that we know the exact value of. Tangent at 30 is square root of 3 over 3. So we could also use that. Okay, and the last problem, number 101, is using them, finding some values on a map. Distance. So it says 3 locations on a map are shown below. And it looks like we know the distance diagonally from Woodbrook to Cedar Knoll, and we know this big angle here is 210, but they want us to find the distance between Lake Crest and Woodbrook, this distance right here. And I drew that for us as well. Okay, so again, we're going to use a reference angle because we want to know from here, this distance. So our reference angle is going to be 210 minus 180, which is another reference angle of 30 degrees. This right here is 30. And this time we know the hypotenuse and we want the opposite. So that should be the sine of 30 degrees. And it is, sine is opposite. So x is opposite over 100. So 100 times the sine of 30 degrees should give me x. I think it should be 50 miles. I'll put it right here. So sine 100 times the sine of 30 should be 50 miles. So it looks like our distance should be 50 miles from Lake Crest to Woodbrook. Pretty cool how we can find that, huh? So catch me back for lesson 5.5 and 5.6. We're building on our understanding of trig functions. It's getting exciting. You're nearing the end of the semester. Keep up the hard work. Reach out if you have any questions. We're going to look at graphs of sine and cosine in the next lesson. It's going to be fun.